Alright guys, part 3 of the elimination method. So the first day we worked on ones with matching coefficients. Yesterday we had to multiply one of them to get them to match. And today we're going to have to multiply both of them because sometimes when there are no common coefficients, we have to multiply one or both equations by a number to create matching opposite coefficients. Okay? So let's get right into some examples here. 3x plus 3y equals 9, and 5x plus 4y equals 10. So we have two options. We can make the x's match or we can make the y's match. But in order to do that, we're going to have to multiply both of them. So we have to find a common multiple. So the least common multiple of 3 and 4 is 12. So in order to get this 3 to equal a 12y, I would have to multiply it by 4. And in order to get this 4 to equal a 12y, I would have to multiply by 3. So I'm going to distribute this through multiplying all the parts. So 4 times 3 is 12x. Plus 4 times 3 is 12y equals 4 times 9, which is 36. Now I'm going to multiply this 3 through. 3 times 5 is 15x. 3 times 4 is 12y. Good, that's what we wanted, right? We wanted matching coefficients. And 3 times 10 is 30. Now we have to subtract the bottom because they're the same. They're not opposite. 12 minus 15 is negative 3x. 12 minus 12 is 0. We wanted that to go away. 36 minus 30 is 6. So I'm dividing both sides by negative 3, and x equals negative 2. Now I'm going to put that back into my equation, right? My initial one. 3 times negative 2 plus 3y equals 9. Negative 6 plus 3y equals 9. So I'm going to add 6 to both sides. 3y equals 15, and divide both sides by 3. Y equals 5. Okay, so now I have my point, and I list it as always x, y. And there's my solution to that system of equations. Okay, see how that required an additional step than we were doing yesterday, right? We tried to add on a step-by-step basis. So 5x plus 9y equals negative 10 for your first equation, and 7x plus 10y equals negative 1. So I have a 5 and a 7 or a 9 and a 10. So I'm going to take my smaller numbers, and in order to get them to be a common multiple, I have to multiply them by each other. So I have to multiply the 5 by the 7 and the 7 by the 5. So now when I distribute that through, I would have 35x plus 63y equals negative 70. And if I distribute this through, I have 35x plus 50y equals negative 5. So remember, I have the matching now, but I'm going to have to subtract one from the other to get rid of it. So 35 minus 35 is 0. 63, and this is really minus 50, is 13y equals, this is really adding, so we have 65. And I know that 13 goes into 65 5 times. Oh, this is negative though, right? Because this is a bigger negative number. I would divide by 13, and I just said 13 goes into 65 5 times, and it is negative 5. So I'm going to take this and put it back into here. So I could say 5x plus 9 times negative 5 equals negative 10. 5x, this is negative 45, equals negative 10. So I'm going to add 45 to both sides, which is 5x equals 35. So I'm dividing both sides by 5. So x equals 7. And I would list my point as x, y. Alright, does that make sense? Adding that one more step? Maybe two more. Let's look at two more. So we have 2x minus 6y equals 12 and negative 5x plus 15y equals negative 30. Alright, so if I wanted these smaller numbers to match up, I need to figure out what the lowest common multiple of 5 and 2 was. So I'm just going to end up having to multiply the 2 by 5 and the 5 by 2. So when I distribute that, I have 10x minus 30y equals 60. When I distribute this, I actually have negative 10x plus 30y equals negative 60. So these were like the exact opposite. So this gives us 0 equals 0. Do you remember what that means? It means these are the same line and we have an infinite number of answers. Alright, well that was a quick one. Now, how about 5x plus 2y equals negative 3 and 3x plus 3y equals 9. So I always start, if I don't have anything in common, no matching coefficients, then I would start with my lower numbers. So I would multiply the 2 by 3 to get 6 and the 3 by 2 to get 6. So we'll have 2 6y's. So if I'm distributing this 3 times 5 is 15x. 3 times 2y is 6y, and 3 times negative 3 is negative 9. So then I'm distributing the 2, so I have 6x plus 6y equals 18. Now I have the same one, so I have to subtract it to get rid of it. So I'm essentially multiplying a negative 1 all the way through. 15 minus 6 is 9x. 6 minus 6 goes away. And then this is actually negative, so I have a negative 27. When I divide both sides by 9, I end up with x equals negative 3. So now I'm going to put that into my equation. Plus 3 times y. I was going to put another number in for some reason. Alright, 3 times 3 is 9, but it's negative. Plus 3y equals 9. Add 9 to both sides. So I have 3y equals 18. Dividing both sides by 3 gives me y equals 6. So I would list it as x, y, and that would be my point of intersection for those two lines. Alright, have a fantastic day.